Click the link in the description to download your own copy of this video's problem. Hey guys, Wes here. Welcome back to another fantastic chemistry video, and today we're going to learn about hydrating double bonds. But before we get into that, go ahead and slap that like button, leave a comment down below, and subscribe to this channel. If you find this video series helpful, if you find me helpful to learn organic chemistry, please slap that like button, subscribe to the channel. It's the best thing you can do to help me out in my endeavor to grow my YouTube channel and my audience. Also, share my content if you know anyone that's struggling with organic chemistry and you think I can help them. I would love it if you did that. Let's get into this. So now we're going to add dilute acid to a double bond, to a pi bond essentially. No problem. No problem. Here's how we do it. Remember, pi bonds are nucleophilic. First thing you have to remember. Pi bonds are nucleophilic, but they're also basic. Remember, the difference between a nucleophile and a base is what's being attacked. All nucleophiles have the potential to be bases. All bases have the potential to be nucleophiles. It's just a matter of what's being attacked. In a base, Bronsted bases attack protons. Nucleophiles attack anything else. Pretty much how it works. So dilute acid, that implies that there's hydronium. Doesn't imply it, kind of shouts it really. So here's my hydronium. Pi bond attacks one of the protons. Electrons go to the oxygen. And a cation forms. So this is very similar to an SN1E1 type reaction. Very similar to an SN1E1 type reaction. Because it forms a carbocation, right? So these things are susceptible to all the same things that SN1 and E1 are susceptible to, including rearrangement. So always look for rearrangements in these questions. This particular one doesn't have a rearrangement, so we're going to move forward. So now water. Because water, the oxygen on water is delta negative, so it's going to be attracted to this positive. It's going to attack the cation. Here's the original proton that we got. Now we got some protonated alcohol happening here. And of course, more water will come in to deprotonate. So now, as I'm drawing this mechanism, I hope you're seeing that this reaction is actually catalytic in acid. It's an acid catalyzed reaction. How do I know that? Well, the first step, we use the catalyst right here, and now we're reforming the catalyst. So here we're deprotonating hydronium. Here we're forming hydronium. So it's catalytic in acid. Remember, a catalyst lowers the activation energy of a reaction, but it also is not consumed in the reaction. So you use it, you get it back, always. That's how catalysts work. If you consume it in the reaction, it is not a catalyst. And there you go. There is the product. And there you go. That's how you do this mechanism. Now, I hope you found this video helpful. If you did, slap that like button. Go ahead and leave me a comment down below and subscribe to my YouTube channel. Share my content with family and friends who may be struggling with organic chemistry. And you know what, guys? With all that, I want to wish you good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.